All right, so I wanted to go over a little bit about what it means to be a chemical formula and what it doesn't mean. All right, so this is from the guided notes 601. If you want to copy this, this is fine. All right, any chemical formula just tells the relative number of atoms of each element in a compound. All right, and the thing is, there's a difference between what a formula is depending on whether you're talking about a covalent compound. You know, another way of saying that is a molecular compound versus an ionic compound. All right, so for a molecular compound, it's pretty simple. All right, the formula just represents the number of atoms of each element in a single molecule. All right, a molecule is just a term for a collection of covalently bound atoms. All right, we've already talked about these, and you'll see more examples of those. All right, an ionic compound, the formula represents the simplest ratio of the positive and negative ions in one formula unit. And we'll talk about what a formula unit means in just a second. But the thing about it is that there's more than one way to define what a formula unit is. All right? So, first of all, let's go back and let me give a little example of this. So, an example of a covalent compound would be something like water. All right, an example of an ionic compound would be something like sodium chloride. All right, remember what holds the sodium and the chlorine atoms together is the positive and negative charges, whereas these guys are held together because these atoms are sharing electrons. Okay, well, a covalent compound, the formula is just the number of atoms that are in each molecule. All right, so this is a molecule of H2O. This is a molecule of H2O. All right. This right here, the atoms within that molecule are H2O, 2 hydrogens and 1 oxygen. All right. So the thing is, with an ionic compound, the formula is the simplest whole number ratio of the atoms in that. All right. So for this right here, the formula is NaCl. All right, notice that it's not Na4Cl4. All right, for an ionic compound, you've got to identify the simplest repeating unit. All right, and for this compound, it would be NaCl. All right, so one thing that I pointed out about an ionic compound is that there's different ways you could define the formula unit. All right, so let me mention something about that. All right, so what would be a formula unit of NaCl? All right. That would be 1. This is another. This is another. This is another. All right, that's 4 formula units. We can abbreviate that FU of NaCl. All right, but the thing is, even though I defined my 4 formula units by circling those right there, that's not the only way I could have done it. All right, I could have said, and I'll use a different color. To do this, I'll use red. All right, I could have said that is a formula unit of NaCl. That, and that. All right, but notice either way that I did it, in this area right here, there are a total of 4 formula units. All right, so let's contrast that with a molecular compound. All right, so for a molecular compound, it's just the number of atoms in each molecule. All right. But ask yourself this. Is that in red, is that a molecule of H2O? All right? That is not a molecule of H2O. All right? A molecule is all the atoms that are covalently bound to each other. This oxygen is not covalently bound to that hydrogen right there. So even though we can do that type of thing with an ionic compound where we could say either this is a formula unit or this is a formula unit. With a covalent compound, it's a lot more cut and dry. All right, this right here, this is one molecule of H2O. This is another molecule of H2O. All right, this is another molecule of H2O, and so forth. All right, so hopefully this helps with the understanding of what the formulas mean, and we'll talk a little bit more about that. So one other thing I wanted to go over was the fact that for an ionic formula, the formula will always be the simplest whole number ratio of the ions. All right. So for example, we were talking about sodium chloride. All right. If you had sodium chloride, it would just be a collection of the atoms like this. And the formula is the simplest whole number ratio of those atoms. That's why this is NaCl, not Na4Cl4. All right, you don't just count how many of each you have. You have to say what is the simplest thing that repeats over and over and over. All right, so NaCl would be the simplest ratio. All right, so the thing is, you don't do the same thing for covalent compounds. All right, for covalent compounds, remember you're just counting the atoms in each molecule. All right, so let's take a look at these two molecules right here. Notice that if you did the formula, if you counted up all the atoms here, this would be C3H 1, 2, 3, 4, 5, 6. The formula for this right here would be C2H4. All right. Well, if we did the same thing that we did for ionic compounds, this right here would simplify to CH2. All right. But we don't do that for ionic compounds. All right. Sorry, we don't do that for covalent compounds. Same thing here. Both of these, if you simplified them to their simplest ratios, would be CH2. All right. But ask yourself, would CH2 give information about the atoms that were in this molecule? No. All right. This molecule, which is a unit of connected atoms, has got 3 carbons and it's got 6 hydrogens. This is a different molecule versus this one right here. This has got 2 carbons and 4 hydrogens. So we do simplify to simplest ratio for ionic compounds. We don't do it for covalent compounds.